Welcome to The Explainer. We constantly hear this buzzword thrown around, China speed, describing the absolutely breakneck pace of their technological innovation. But today, we're doing something a little bit different. We are literally lifting the hood to look at the exact, meticulously engineered machinery that makes that speed possible in the first place. We're talking about the talent, the supply chains, and the massive data ecosystems. Okay, let's dive right into this.
To really wrap our heads around the sheer velocity of this ecosystem, we have to start with a single number, 11.4. Recently, there was this world's first robot marathon featuring both human runners and machines. And a Chinese humanoid robot named Bolt didn't just participate, it actually ran at 11.4 meters per second, practically shattering human limits. This wasn't just some lucky fluke either, it's the direct result of an environment that has been built purely for speed. So how exactly are they pulling this off? Think of these 5 areas as our blueprints for today. We'll be walking through the AI native generation, the hardware prototyping engine, state-led data centralization, the public-private symbiosis, and finally, setting tomorrow's standards.
All right, Section 1, the AI native generation, cultivating the seeds. Every massive engine obviously needs fuel, and here, that fuel is human capital. Let's look at how this ecosystem is being deliberately seeded right from primary education.
Think about your standard traditional classroom. Now, contrast that with a public elementary school in Hangzhou today. The school day literally begins with a facial recognition AI system just to take attendance. The government's goal here is incredibly explicit. They want to ensure the entire generation born in the 21st century is intimately familiar with technology. By making AI education mandatory in primary schools, they're consciously raising what you could call an AI native generation. And this integration goes incredibly deep. When students write essays, they submit them digitally. Then, an AI program scans the context and structure, and it grades them in just 15 minutes. That data is instantly pushed out to the principal, the parents, and the teacher. Now you might be wondering, why does this matter? Well, it completely frees educators from administrative grading, so they can focus on personalized interaction, all while immersing kids in cutting-edge tech every single day. It's a real game changer. To put a human face to this strategy, meet Yao Siki. He is a 15-year-old student who built a micro-drone that hits a staggering 358 kilometers per hour. Absolutely wild, right? But the real takeaway here isn't just his individual genius, it's the system backing him. His school actively funded his lab space, explicitly telling him that the money was there for him to fail and try again. It's this proactive, deliberate incubation of extreme engineering talent from a very, very young age.
Moving right along to Section 2, the hardware prototyping engine, the accelerator. Once you cultivate that incredible young talent, you clearly need a way to accelerate their ideas. That's exactly where the physical manufacturing supply chains come into play.
Consider the speed of this rapid prototyping cycle. An engineer can conceptually design a part in the morning, hand it over to a peripheral manufacturer just down the street, have it assembled locally that exact same afternoon, and literally prep it for mass production immediately. There is no waiting weeks for international shipping. The entire manufacturing ecosystem is so densely localized that it radically accelerates the trial and error process.
To truly grasp the sheer, overwhelming scale of this hardware engine, consider this number. As of February, there are an estimated 1 million registered robot-related companies in China. 1 million! It is an intensely competitive, completely cutthroat arena where companies are fighting daily to survive, innovate, and capture their piece of the market.
And the result of that hyper-competitive, high-speed iteration is just staggering. Chinese companies now account for a massive 87% of all global robot shipments. They have effectively monopolized production volume by taking that raw engineering talent we talked about and combining it with instantaneous, localized manufacturing.
Which brings us to Section 3, state-led data centralization, the brain. So we have the human talent, and we have the physical hardware. Now let's look at the invisible architecture acting as the brain for all these machines. A huge focus here right now is a concept called physical AI. Simply put, this is the integration of artificial intelligence into physical robotics to execute real-world movements. And this is a totally crucial point. The government isn't just sitting back hoping a market naturally develops for this. They are actively forcing one into existence by pushing AI integration directly into their massive domestic manufacturing sector.
But obviously AI needs data to learn, right? And the state is stepping in to provide it at an unprecedented scale. At just a single training base in Beijing, they've collected 16,000 hours of robot training data. Just imagine human operators repeatedly, meticulously performing tasks over and over again, just so robots can map the exact movements, pressure, and speed required to replicate them flawlessly.
The macro strategy at play here is honestly brilliant. The state pools training data from 9 national centers and 240 different robots, flowing all of that directly to the central government. To put this into perspective, think about how Tesla collects driving data globally. If you aggregate all the robotic and driving data collected by the state across Chinese companies, it actually surpasses even Tesla's massive data sets. And in the global AI race, whoever has the most data learns the fastest, period.
All right, on to Section 4, the public-private symbiosis, the unstoppable loop. This really brings us to the core engine, how the state and the private sector interact to form an incredibly fast, almost unstoppable development cycle.
It essentially operates as a perfect trade-off. The state provides the heavy lifting, capital, massive centralized data collection, and highly lenient testing environments. In return, the private sector takes those resources to rapidly iterate, build commercial products, and perform live market testing. The data generated from those live tests then flows right back up to the state, making the central AI even smarter. It's literally a perpetual motion machine of innovation.
Economic analysts make a really fascinating neutral observation about why this works so efficiently in this specific context. They contrast U.S. leadership, which is quite often comprised of legal professionals primarily focused on protecting rights and balancing voices, with Chinese leadership, which is predominantly made up of engineers. When engineers run a system, they tend to view society as a complex mathematical exercise, where building physical infrastructure is simply the logical solution to nearly every problem.
A perfect example of this engineering mindset in action is what's called the low-altitude economy. This is a highly prioritized national project focusing on the airspace below 1 kilometer. Rather than waiting years for regulations to be perfected in theory, the state has permitted actual city skies to be used as live, real-world laboratories. This leniency allows drone taxi companies to rapidly prototype, test in real conditions, and speed toward commercialization faster than anywhere else on Earth. Finally, we arrive at Section 5, setting tomorrow's standards, the ultimate goal. Let's conclude by zooming out a bit. We've seen this massive educational, manufacturing, and data ecosystem, but what is the ultimate objective? Where is this all actually heading?
First off, the future requires immense power. You absolutely cannot fuel an AI-driven society without massive amounts of electricity. Enter the Dunhung solar plant. It uses 12,000 mirrors spread across a desert to concentrate sunlight into a central tower, basically acting like a giant battery that generates power 24/7. The state is proactively building this staggering energy infrastructure in the West, specifically to power the data centers and factories in the East.
This energy project perfectly illustrates the overarching trajectory here. For decades, China was simply known as the world's factory, right? Manufacturing goods that were designed elsewhere. Today, they are centralizing data and rapidly innovating in-house. But the true endgame is a state initiative called China Standards 2035. The objective is a complete paradigm shift, transitioning from simply making things to writing the global technological standards that every other country will have to adopt.
Which leaves us with one final thought to chew on. We've traced the entire pipeline today, from AI-native middle schoolers to instantaneous supply chains, all fueled by state-centralized data. It's a meticulously engineered ecosystem designed to turn speed into global dominance. So, what happens to the global economy when the world's factory officially becomes the ultimate architect of tomorrow's technological standards? It's a massive shift that will undoubtedly redefine how technology is built, governed, and used for the rest of the century. Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.